All right, boys and girls, here we go. 7-16 is the first homework problem you guys have, and it says, sometimes what you know about relationships can help you predict what data will look like when it's graphed for each situation below. All right, this is what we're going to do. We're going to look at all of them, and from our life experiences or from what we know about being alive, okay, we're going to see as one increases what happens to the other. Kind of like what we talked about with the odometer reading and the cost of the car. So as whatever happens, it goes up. So this is a positive, right? That one's a positive association, meaning that we can describe this in a positive direction. This one's the opposite. As blank goes up, it decreases. The third one is just random. Remember how I was doing this? That's random. And this one is saying that it's just going to stay consistent. As time increases, it's not like it goes up or down. It just stays the same. So kind of like, try to think of an example off the top of my head. Can't do it. Come back to it later. So A, how fast a dog can run and the length of the dog fur. So based on your life and what you think of dogs, if you've been around a dog or seen a dog or wanted a dog, do you think dogs run faster depending on the length of their fur hair? So if their fur hair went up, if the fur length increased, what do you think is going to happen to the speed of the dog? So shorter haired dogs are blank, faster, slower than longer haired dogs. Well, let's think about it. Do you know a long haired dog? I don't know. Does someone in here know a long haired dog? You guys can be a part of my class. No. A long haired dog. Come on, Daisy, you know dogs. Give me a long haired dog. I'm literally going to look up long. Oh, what did you say? Silky Terrier? Now this video is going to become longer than 5 minutes, 3 minutes, because I'm talking about freaking dogs. Oh, look at this one. What is this? Long hair, don't care. Look at this. Would you look at it? Just look at that. Do you think these dogs are just faster because they have long hair? Or do you think that it matters? Oh, there's one you're talking about. I don't know. That's just, sorry, that looks like a mop. Straight up, look at this. Looks like a mop. I'm sorry. My food is ready. Well, here, I'm putting it up on the screen so you guys can see. That dog literally looks like a mop. Do you think that dog is faster because it has long hair? I don't think so. So, does the length of the dog hair matter? No. So that's going to tell us graph 3. Because as the dog hair increases, so short hair, long hair, doesn't matter. Does it matter how fast they are? No. The dog's going to be fast if it's fast or slow if it's slow. I think it really depends on how fat it is and if it's a strong dog. Come on, think of a pit bull. Do you think they're faster than a German Shepherd? You think a pit bull is faster. They're short and they're fat. German Shepherds are tall and they're long. Okay, so I guess it really doesn't matter. So, it's random. A person's age and their body temperature, well, if you think about that, if you literally Google a person's temperature, it does not change over time. It doesn't change if I'm old or if I'm young, unless I'm dead. And that's how I explained it to my honors class. If I die, my body temperature is going to go down to 0 because there is no temperature for my body to keep. But if you are alive, you're going to have a pretty steady temperature. The next one, a child's age and the shoe size of his or her feet. Well, when I was 0 years old, when I was born, my feet was not as big as it is right now. So here's my shoe. When I was a baby, I would not fit in this shoe. So as a person ages, and this is a child, so think of you. When you were in 3rd grade and when you're in 8th grade, do you think your shoe size increased or decreased or stayed the same? Or was it just random? When you're 2, it's big. When you're 5, it's small. And then when you're 6, it kind of goes in the middle. You never know. That's not going to be true. So that's going to be the first one. The last one, outdoor temperature and the percent of people wearing long sleeve shirts. So the hotter it is, what happens to the number wearing long sleeve shirts? Well, if it's 100 degrees, do you think I would wear a sweater? Yes. You think I'm crazy? So please stop. Now you're interrupting my teaching. If you go outside and it's hot, the percent, so some people might, but majority of the people, do you think they're going to be shirtless in Santa Barbara, or do you think they're going to put on a puffy jacket, put on their raincoat after that, put their boots on in 100 degrees? I don't think so. So that's going to decrease as the outdoor temperature increases, right? As that goes up, what happens to the amount of people wearing long sleeve shirts? That's how you do this kind of problem. Took 6 minutes for me to go over that. I hope you're watching it in 2 times speed. So your job is to do this one. Peace out.